Hey guys, in this video we will be reviewing how to find the solution in a systems of equations. Before we can begin, you have to understand what a solution means. You have three different types of solutions. The first one is going to be one solution. That is where, let me write this down, make sure you have pencil and paper so you can take notes. You have lines that intersect once. Like an ordered pair. You're going to have one particular point where those two graphs are going to intersect. That is going to be the solution. So let's say, for instance, if I have a system's y equals 5x plus 3, and I have another one, my other equation in the system, because remember, for it to be a system, it must be at least two equations. 3x plus 6. I'm going to go to my calculator over here. I'm going to go to y equals. I'm going to put my first equation in, 5x plus 3. And then I am going to arrow down and I'm going to put my second equation in, which is 3x plus 6, and I'm going to graph it. Now on this particular calculator, the graph is like zoomed all the way out. In the cutout video, I'm going to be showing you how to zoom that graph in. Use two fingers to move it around. You have to have two fingers down. But you have to zoom it out on the x-axis and on the y-axis. Almost there. Okay, I got one. I'm going too far. Just take this back in some. You just have to play around with it a little bit too. There we go. So now you can see 1, -1, 1, -1, 1, and -1. So use your two fingers to move. But this is the part that I want you to see. You can hit trace down here. Trace. Take one finger and you will see a blue dot and a red dot. You see a blue dot and a red dot getting closer together. At the point that they cross, that they are right on top of each other, that's going to be the intersection of this particular system. So again, you have to have two different equations that when you graph them, they're going to cross at some point, and they're only going to cross once, and that particular point is going to be the solution. Another type of solution that you could have would be a no solution. This means the lines are parallel and have the same slope. And have the same slope. Okay, let's say I'm given y equals 2x plus 1, y equals 2x plus, let's say 3. Let's go to our calculator here. We're going to clear out what we had. We're going to put these two equations now. 2x plus 1, go down, 2x plus 3. We're going to graph those. I can zoom out here if I wanted to, but if you see these two graphs, this red and blue line, they're going to always continue to run right along each other, but they're never going to touch because they're parallel, because they have the same slope. So if you have a systems and you see that it has the exact same slope, you know from there that you're going to have a no solution system, because you're not, the lines are never going to, they're never going to intersect. They're going to forever be parallel. The last type of solution is going to be infinitely many solutions. That means that pretty much the equation, I'm just going to give you an example of the equation. It's going to have the same slope and the same y-intercept. I'll just make that note. Same slope and y-intercept. Same slope and y-intercept. So that's basically just saying like 6x plus 1, y equals 6x plus 1. Same slope, same y-intercept. If I type those in here, just to give you a visual, 6x plus 1, 6x plus 1 graph. You can really only see the red line because they're the exact same equation. Let's see if I think I can switch it to the blue up here at the top. Yes, now you can kind of see the equation for the blue, but you still can't see the blue line because they're directly on top of each other. So again, with systems of equations, you're going to have three different type of solutions. One solution where the lines intersect once, no solution. It's going to forever be parallel because they have the same slope, and infinitely many solutions because the two equations are going to have the same slope and the same y-intercept. All right. So let's just jump right in with a system here. We have a system y equals negative 3x plus 4 and y equals negative 3x plus 2. Well, since we're here, let's just go ahead and let's practice graphing. It wants to know what's the solution of this system. Now, you have different ways that you can solve systems of equations. One way, and to me, I believe would be my favorite, is to graph. Remember, if you have an equation, we're going to look at this graph right here first. If you have an equation, the last number, the one without the variable, that's going to be your y-intercept. So let me notate my graph here. We have our x-axis and we have our y-axis. So if this 4, positive 4 is my y-intercept, I want to go to positive 4 on the y-axis, and I want to put a point there. Now I have a slope of negative 3. So remember, slope is, make a note, slope, rise over run whenever you are graphing. So that means that my slope is going to be 3 over 1. And the reason why I can put that 1 there, because 3 divided by 1, it equals 3. That's the reason why we don't have to write negative 3 over 1 over here. So let me erase that there. Well, I can keep that. So yes, I have a slope of 3 over 1. But not only is it just 3 over 1, it's going to be negative. So when you have a positive slope, remember, regardless of if it's positive or negative, you're going to always go up on your y-axis. If it's negative, you're going to go to the left. And if it's positive, you're going to go to the right. But since I don't have enough space to go up, you would just do the opposite. I would have went up into the left 1 because it's a negative slope. But since I can't go up, I'm going to go down into the right 1. I'm going to do the exact opposite. So I'm going to count down 3. 1, 2, 3, and over to the right 1. And I'm going to put a point there. I'm going to put a point there. Okay. Now I'm going, oh, sorry. Give me 1 second. Thing here kind of messed up on me and switched up. There we go. I don't know how that happened. Okay. 4. I'm going to go down. 1, 2, 3 over 1. 1, 2, 3 over 1. You can keep going as far as you would like. Really, 2 or 3 points will be enough. And then I'm just going to connect my graph. Hopefully I can make this as perfect as possible. Okay. So that, the red graph is this one right here. I'm going to draw this one in blue. This one I have a y-intercept of negative 2. So I'm going to put a point there at negative 2. And then I have a slope of positive 3. So it's going to be 3 over 1. So my rise is going to be 3. And my run is going to be 1. It's positive, so I'm going to go up 3 into the right 1. So 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. I can go ahead and I can just draw my graph here. It's kind of ugly. But if you see right here, the point that these two graphs cross is going to be right here at the point 1, 1. And I know that it's 1, 1 because remember, you can put your pencil on the point, drag it to the X and Y. Drag it to the x-axis first. Remember, the reason why you want to go to the x-axis is because of order pair, x comes first, just like an alphabet. An x point and then a y point. So my x point is 1, and my y point, put it back on the point, drag it to the y-axis. It's going to be at positive 1. So my solution for this particular system is going to be 1, 1, because this is the point that these two graphs cross. Now, that is one way that you could solve this particular problem. Let's talk about another one here. We have two equations that's already solved for y. I'm going to go to my calculator. I'm going to go to y equals, clear this out, and I'm going to type in my two equations. Negative 3x plus 4, 3x minus 2. I'm going to hit graph. Remember, we want to do the same thing that I showed you in the beginning. Just zoom it in. Zoom it all the way in to where you can see 1, -1, -2. 2 fingers to move it around. Try to stay where you can see the origin, 0, 0. There we go. It's the wrong way. There we go. All right. You can kind of clearly see that the point is going to be 1, 1. But you can hit trace down here at the bottom. Take a finger, and you want that red and that blue dot to be right on top of each other. Right on top of each other. And then once you have them as close as possible, you want to look at the top here. In the red, you see a X is equal to something. A Y is equal to something. In this case, my dots, they're not exactly on top. So I see that X is equal to 0.99. Y is equal to 0.99. Rounds up to 1. But I'm telling you, I know that if you just really kind of play around with it, you can line up the dots directly. It's kind of like a game. Because I sat and played with it for a while. But you can line them up directly, and you can eventually get, to the exact point. But that is another way that you can solve it is with this particular calculator. If you're using the calculator that you downloaded online, remember the steps. You want to go to y equals. You want to put in your equation y1, y2. You want to hit graph. Oh, I'm sorry. Let me grab my calculator. Calculator. All right, as a matter of fact, let's do this. On your calculator, if you are using the one that you downloaded online, you will go to y equals. You will put in your equation, 3x plus 4. Oh, that's not right. Clear. Negative 3x plus 4. Go down to 3x minus 2. 3x minus 2. And you're going to go to second trace. 5 for intersection. It's going to graph here. One, 2, 3. You're going to see intersection, and it's going to say x equals 1 and y equals 1. And that was indeed our answer. All right, let's get some more examples here. In this one right here, 2x minus 3y equals a negative 1. And then the other equation is y equals x minus 1. I'm going to show you a way called substitution. So we already have one equation that solves for y. This says that y equals x minus 1. So if y equals x minus 1, I can substitute that where I see a y in this first equation. So let's do that now. So I'm going to write down 2x minus 3. Instead of writing y, I'm going to write what y is equal to. And y is equal to x minus 1. X minus 1 equals negative 1. Now, remember, when you have to distribute, you have to take what's on the outside of this parentheses and multiply it to everything on inside the parentheses. So that's a negative 3 times x and a negative 3 times a negative 1. So let's do that now. 2x, what's negative 3 times x will give you negative 3x. Negative 3 times a negative 1 will give you plus 3 is equal to a negative 1. Now let's look at our like terms. Well, we have 2x and negative 3x. Those are like terms, so we can combine those together. So 2x minus 3x, well, that will give you a negative 1x plus 3 is equal to negative 1. Do I have to write this 1? No, I don't have to write that 1. So this is really negative x plus 3 is equal to a negative 1. Remember, I'm solving this equation for x. So I'm trying to move everything away from my x. So if I do something to this side of the equal sign, I have to do the same thing to this side. So what that means is if I'm trying to move everything from my x, I need to move this positive 3. Well, the opposite of positive is negative. So I can move that by subtracting 3 on both sides of the equal sign. These 3's will cancel out because a positive 3 minus 3 is just 0. And I'll be left with negative x is equal to negative 1 minus 3. Well, let's go to our calculator if you don't know. Negative 1 minus 3 Well, that will give you a negative 4. So I have negative x minus negative x is equal to a negative 4. Now, remember, we said that this is just like saying a negative 1x. And a negative 1x is basically saying negative 1 times x. So the opposite of multiplication would be division. So to isolate this x on the side, I need to divide by a negative 1 on both sides. These negative 1s will cancel out here, and I will just be left with x. So x will be equal to negative 4 divided by negative 1 will give you a positive 4. So my x is a positive 4. Let's go ahead and write that up here. My x is a positive 4. Got an add going on in my calculator over here. Let's just get out of there. Okay, so now that I know what my x is, I need to figure out what my y is. So now that I have an x, I can substitute my x right here, my 4, and I can put it where I see an x in this bottom equation. So let's do that now. So I have y is equal to, instead of writing x, I'm going to write 4. 4 minus 1. 4 minus 1 equals 3. So my y is going to be equal to 3. So I have my x is equal to 4, and my y is equal to 3, and my ordered pair will be 4, 3. Now that is the substitution way to solve these type of problems. Now let's look at it if you just wanted to go right to your calculator and you wanted to solve this problem from your calculator. We know that this is our solution right here. I'm just gonna keep that up there. Just gonna keep that up there. But let's go and let's look at, let me rewrite our problems right here. 2x minus 3y equals negative 1. Y equals x minus 1. Let's just say that you're starting over from fresh. This is your problem. And you say, I don't want to do substitution. I want to do the calculator way. Okay, well, you already have an equation that's solved for y. So you don't have to do anything to that one. But this one, you have to solve it for y. How we solve for y in this class is cross method. Remember, change x. If it's positive, make it negative. Keep answer. Negative 1, keep y. Negative 3. You're going to be dividing from top to bottom. Remember, this column gives you your slope, and this one gives you your y-intercept. So you're going to be dividing top to bottom, like I said. Negative 2 divided by a negative 3 will give you a positive 2 over 3. Negative 1 divided by a negative 3 will give you a positive 1/3. You can go ahead and write your answer. Y equals x goes behind the slope, and since this is positive, just going to be a plus sign. So now I have two equations. I have two equations now that solve for y, and I can go to my calculator. Let's go right here. I can go to y equals. Let's clear all of this out. Go to y equals, and I can put in my first equation, x minus 1. I can go to my second equation, 2/3 x plus, I think that was 1/3, yep, plus 1 divided by 3, and I can graph it. Now I can zoom in on this graph so I can see the intersection a little bit better. But once you kind of zoom in, you can hit trace at the bottom, and you want to line those dots up, that blue and that red dot, right on top of each other. You want to line them up as close as you can get them. And I see right here in red at the top, I see an X that says it's 4 and a Y that says it's 3. If I'm not mistaken, that's what we got for our answer. So you can solve this particular problem two ways, using either substitution or making sure both equations are solved for y, and you can go to y equals in your calculator. All right, let's take a look at one more problem here. Let me get the problem. All right, let's say we have 4x minus 3y equals 18. And my other equation said y is equal to negative 2. Pause this video and see if you can find the solution for this particular problem. Okay, if you look at this problem here, we have one equation. It's not solved for y. This is not solved for y. Not solved for y, but this one is. And not only is this one down here solved for y, but it's nothing else with it. It's saying that y equals a negative 2. So we know we're looking for an x value and we're looking for a y. And we already know that our y is equal to a negative 2. So in this problem, we really only need to find our x. So I can take my y, which is equal to negative 2, and I can substitute it wherever I see a y in its original problem. So let's do that now. 4x minus 3 times negative 2 equals 18. Now I can just solve this equation for y. For x. I'm so sorry. 4x negative 3 times a negative 2 will give you a positive 6 equals 18. I'm trying to isolate x, so I need to move this 6. The opposite of positive is negative. So if I do it on one side of the equal sign, I must do it on the other side of the equal sign. So minus 6. These 6's will cancel, and I will be left with 4x is equal to 18 minus 6 will give you 12. Trying to isolate opposite of multiplication would be division. So I'm going to divide by 4 on both sides. And I'm going to be left with, these are canceled, I'm going to be left with x is equal to 12 divided by 4 is 3. So I have my x, which is 3. I have my y, which is negative 2. So I know that my solution is going to be 3, negative 2. That will be my solution. Okay? Now, let's do it the calculator way now. We have one equation, y equals a negative 2. And then we have our other equation. Let's erase all of this really quick. Let's do cross method. Change x, negative 4. Keep answer, 18. Keep y, which will be a negative 3. You're going to divide from top to bottom. Ready to write our answer. Y is equal to negative 4 divided by a negative 3 will give you a positive 4 over 3. X, 18 divided by a negative 3 will give you a negative 6. So that will be minus 6. So now I have one equation, two equations. Let's go to my calculator now. Y is going to be equal to, let's clear these out. Y1, I can just put negative 2. Y2, I can put 4 divided by 3. X minus 6. Graph. Zoom in. Zoom in. You can hit trace. Let's see where those red and that blue cross at. Try to get it as close as I can. Let's try to get it a little closer. There we go. It says right here in blue, x is equal to 3.01. Say x is equal to 3. Y is equal to a negative 2, which is indeed the correct answer. All right. There may be a time that you're giving two tables and they ask you, what is the solution to the system of equations represented by these tables? Now, the only thing that you really would have to do is to actually look at the table and see, do any 2 points look the same? And in this case, we do see 2 points, 3, 2, and 3, 2. But I want to visually show you. We know that the solution for this table is going to be 3, 2 because the point is in both of the tables. That means that that's the point that they're going to intersect. Let me give you a visual of it. Let's plot these points. I'm going to do this table in red and this one in blue. So the point 2, 4. Going to go over the 2 on the x-axis, up 4. 1, 2, 3, 4. Going to put a point there. 1, 6. Going to go over 1 on the x, up 6. 1, 2, 3, 4, 5, 6. And then 3, 2. Going to go over 3. 1, 2, 3, up 2. 1, 2. And now I'm going to draw my graph. Okay, now I'm going to draw this one in blue. 3, 2. 1, 2, 3, up 2. Got a point right here. 1, 4. 1, up 4. 1, 2, 3, 4. Have a point right here. And then 6 and negative 1. 1, 2, 3, 4, 5, 6. And down, negative 1. Now I'm going to draw this graph. And if you see here, indeed, the point that these two graphs intersect is right here. And that's going to be at positive 3, positive 2. So the point would indeed be 3, 2.